Good morning, students. So today we will discuss about how to write the electronic configuration. You can take any elements, right? Actually this is a trick just to be write down, no need to be remember the long electronic configuration, right? So we can easily remember the trick just to be write the electronic configuration. So come for in terms of here. So here there have been the three orbitals. So that is an s orbital, shall we write down here, an s orbital, and p orbital, and d orbital, and f orbital. There have been the four orbitals that one you people already know, right? So in s orbital, the capacity of electron that has been filled only the two electrons. The capacity of electron in s orbital, that is the two electron only has been filled. Come for the p orbital, there have been the 6 electrons, and come for the d orbital, there have been the 10 electrons, and come for the f orbital, there have been the 14 electrons, right? So the maximum capacity, so the filling is for s that is 2, and for the p that is 6, and for the d that is 10, and for the f that is 14 electrons, right? So for this one just we can write on the orbitals. So here it is an 1s orbital, we should write down like this, 1s, and then come for the second one, that is 2s and the 2p, right? And come for the next, that is 3s and 3p and the 3d orbital, that is an 4s and 4p and 4d and 4f. See here, SPDF, right? So in s orbital, this orbital contain only s orbital only, and here it is 2s and 2p. Come for here, it is 3s, 3p and 3d. Here 4s, 4p, 4d and 4f. Come for here, it is 5s and 5p, 5d and 5f. 6s, 6p, 6d and 6f, 7s and 7p, like that only. Just you can write after that. So but in terms of here, you should go for just write on the arrow mark here. See here, this arrow mark. Right. So come for this one here, just see properly here. So the obviously the arrow mark here, it is in this direction. So after the one electron, the electron that has been filled in the 1s, after the electron filled in the 1s, it will be again go back from this one, and again it has been filled in the 2s, right? So again the arrow mark here, so it will become from starting from here, and it is 2p and then 3s, and then it is 3p and it is 4s, right? So see the arrow mark here, and again it will go back, that is 3d. After 4s it is 3d, and then 4p and 5s. Again it will go back, that will get 4d, 5p and 6s. Again it will go back 4f, 5d, 6p and 7s. Again 5f, 6d and 7p, right? So like that only. This we have to be, so arrange the orbitals. After that we have to be filling the capacity of the orbital. Just I will give you example also. Just remember that one. Just in terms of here, after 1s, see the arrow mark, the direction of the arrow mark. Right, the direction of the arrow mark after 1s, it has been filled the 2s, right? So after again it will go back, and it is 2p and 3s. Again it is 3p and 4s. See the direction, and again it will go back 3d, 4p and 5s. Again after that it is 4d, 5p and 6s. Like that only you have to be fill the capacity of the electrons, right? I will give one example. For example, so just I want to be write the electronic configuration of the chlorine atom. Right, the chlorine atom. You people have been know the atomic number of chlorine. So that is 17. Right. So the atomic number of in terms of here. So the chlorine atom is 17. So this is also been we have to be remember. So the s orbital containing the field that will only 2 electron, and the p orbital 6, and the d orbital 10 and the f orbital that is 14. Okay, write the electron configuration of chlorine. So it is 1s. How many electron? The 2 electron get filled, right? So we have to be filled the electron until that has to get satisfied 17. That has to get satisfied 17. Up to that we have to be fill the electrons. So that is 1s2. After that it is the 2s. S orbital also been 2 electron. After that we go for the 2p, right? So here it is 2p. How many electrons? 6 electron. Total there have been the 10 electrons has been filled. After that it is the 3s also been 2 electrons, and after that it is 3p, right? So 3p is maximum is 6 electron. So see here, 2 plus 2 4, 4 plus 6 10, 10 plus 2 12, right? So we require how many electrons? Still we require only the 5 electrons to satisfy 17. So now it will become 5. So this is the electronic configuration of the chlorine atom. So that is 1s2, 2s2, 2p6, 3s2 and 3p5. By using this one we can easily write whatever. If we go for 100 atomic number, we can also 100 electronic 100 times also we can write the electronic configuration, right? Come for one more example. So that is if it is in terms of here the calcium, right? So atomic number of calcium is 20. The atomic number of calcium is 20. So electronic configuration here the same thing, 1s2. So again that is in 2s2 and 2p6, right? So 2p6 and 3s2. After 3s2 again we have to become here 3p, right? So that is in 3p6 and again it is the 4s2. See the electrons. So this number we are called electrons, right? So 2 plus 2 4, 4 plus 6 10, 10 plus 2 12, 12 plus 6 18, 18 plus 2 20. So atomic number 20, right? So still more example I'll give. For example the zinc, right? Zinc atomic number is 30. Atomic number is 30. By using this one trick you can write the electronic configuration very easily, right? So no need to be remember so all those orbitals, right? If we go for zinc, so that is in 1s2 and 2s2 and 2p6 and 3s2 and here it is 3p6. After that it is the 4s2. After 4s2 that is 3d, right? So d orbital containing how many electrons? Maximum is 10 electrons, that is 3d10, right? So now count the number of electron. 2 plus 2 4, 4 plus 6 10, right? 10 plus 2 12, 12 plus 6 18, 18 plus 2 20, 20 plus 10 30. So that is atomic number 30, right? So we'll give one more higher example. So that is the krypton, Kr, krypton. So atomic number is nothing but the 36. It's a it's a noble gas. It's a noble gas. Atomic number is nothing but the 36. If we go for electronic configuration, again same. So there is an 1s2, same here. After that it is come to the 2s, that is 2s2. After that it will come to the 2p6, right? So 2p6 and then 3s2. After that again 3p6, again 4s2 and 3d10, right? So 3d10 up to here the number of electron that is 30, right? Still we require about 6 more electrons. So 4p that has been get filled. After 3d that is we'll go for the 4p6 electrons, right? So 2 plus 2 4, 4 plus 6 10, 10 plus 2 12, 12 plus 6 18, 18 plus 2 20, 30, 36, right? So this is nothing but the methods. We can write the electronic configuration whatever it may be the element, just you should know only the atomic number, right? So by using this one we can easily write the electronic configuration, right? So this is a simple method, but we have to be also been remember the s orbital containing the capacity of s orbital containing 2 electrons, the capacity of p orbital containing 6 electrons, the capacity of d orbital that is 10, the capacity of f orbital that is the 14 electrons, right? Understood? Okay, right? So we go for some other topics. We'll go for some other topic, that is an isotopes, right? So there have been the isotopes, isotopes and isobars. Isotopes, isobars and isotones. Isotopes, isobars and isotones. Right. So just we can come to know what do you mean by isotopes. Right. I will give an example. So that is in terms of here the hydrogen atom. So this one we are called protium. Right. So the protium. So here in this protium it will be containing one atomic number is 1. The mass number is also been 1 only. Atomic number is 1. Mass number is also been 1 only. So if we go for one more atom, so that is atomic number is 1, but the mass number is 2. This one we are called and deuterium. This one we are called deuterium. This one is already we have been discussed about in the last class only. So come for one more. Atomic number is 1. The mass number is 3. This one we are called tritium. This is called and tritium. See here. So the atomic number is 1. Here atomic number is 1. Here atomic number 1. If we go for mass number, the mass number of the protium is 1. The mass number of deuterium is 2. The mass number of tritium is 3. Right. So this one we are called isotopes. The atom which containing same atomic number but different mass number. That is called isotopes. The atom which contain same atomic number but different mass number is called an isotope. I will give one more example. So for example, the chlorine. So atomic number of chlorine is 17. So the mass number is N35. Just I will take one more. So the isotopes of chlorine atom, that is N17. Here it is N37. Right. 37. So if you go for here, if you consider this one, the atomic number of both the atoms have been same. Right. Atomic number of both the atom has been same, but the mass number here it is 35, here it is 37. That is different. That one we are called isotopes. Right. The atom which contains the same atomic number but different mass number. The atom which contains same atomic number but different the mass number is called an isotopes. Understood? Come for next one. That is an isobars. Isobars is the reverse of isotopes. Isobar is the reverse. It's the reverse of an isotopes. I'll give an example. So that is in carbon, and if we go for the nitrogen. Right. So the isotopes of carbon atom, that is a 14. Here it is also been 14. Here it is atomic number is 6. Here atomic number is 7. Right. So now only you can easily explain what do you mean by isobar. It's the reverse of isotopes. It's a reverse of an isotope. Right. So here it is in isotope, the atomic number is same. Right. So but mass number is different. If it become for isobars, here the mass number is same, but the atomic number is different. The mass number is same here, but the atomic number is different. That one we are called an isobar. Right. So the atom, the species which containing same mass number but different atomic number. The species or atoms which contains the same mass number but different an atomic number is called an isobar. Right. So come for we will go for isotones. Right. We will go for isotones. Take the color chalk. If we go for isotones, right, here in this isotone case, so that is in the carbon, the oxygen is in terms of atomic number of carbon is 6, here it is in terms of the 14. If we go for oxygen, so atomic number is 8, here the mass number is 16, right. So this is an isotope, isotopes of carbon atom, right, isotopes of the carbon atom, this one. So here in this case, how many neutrons have been present in this carbon atom? That is 14 minus 6, that is 8 neutron. The 14 minus 6, that is an 8 neutrons have been present. 8 neutrons. Right. If we go for here in this one, 16 minus 8, that is here also been 8 neutrons. 8 neutrons. Both have been the same neutron. They are called isotones. They are called isotones. The species which containing the same number of neutrons. The species which containing or atom which containing the same number of neutrons, we have been called isotones. Right. So this has been very important one. So isotopes and isobars and isotones. Right. So what do you mean by isotopes? Isotopes are nothing but the species which containing same atomic number but different mass number. Is called isotopes. Isobars is a reverse of isotopes. Right. The atom or species which contains same mass number but different atomic number. Is called isobars. If it become for isotones, the atom which contains same number of neutrons, they are called isotones. Right. So we'll go for one more. So what do you mean by isoelectronic species? It's been very important for competitive exam also. Isoelectronic species. It's been very important for competitive exams also. They will be already asked a few questions based on this one. So if we go for the nitrogen atom, here it is nitrogen. Just assume it's a proton, okay, electron and proton. So if we go for here, if it is in ionic form, that is an N3 minus. Here in this N3 minus, so this 3 minus indicates 3 rich of electrons. This 3 minus indicate the 3 rich of electron. The 3 electrons are extra. The 3 electrons has been extra. So here atomic number of nitrogen is 7. So 7 plus 3 means there have been the 10 electrons. If we go for protons, as it is the atomic number. If the atomic number is 7, there have been the 7 protons. Right. So the number of protons are 7. If we go for here O2 minus, so again the number of electrons has been 10. The protons are 8. If we go for here, it is an F minus. The number of electrons are again 10 because atomic number is 9. 9 plus 1, 10. So the protons are 9 only. If we go for here Na plus, the number of electrons, because atomic number is 11, this plus indicates the deficiency of electron. Thus plus indicates the deficiency. 1 plus means 1 electron is less as compared to the atomic number. So atomic number of sodium is 11. 1 plus means 1 electron is reduced. So that is again it will become 10. Number of protons, that is 11. So if we go for an Mg plus 2. Atomic number of magnesium is 12. Plus 2 means we have to be reduced 2 electrons. So then again it will become 10. So the number of protons are 12. So this one we are called isoelectronic species. The species which containing the same number of electrons. The species which containing same number of electrons but different number of protons. They are called isoelectronic species. The name itself indicate iso means same, electronic means electron, same electron. Right. The name itself indicate. Name itself indicate. Iso means same, electronic means electron. Same number of electron but different number of the protons. Is called isoelectronic species. The species which containing the same number of electron but different number of the protons is called an isoelectronic the species. Right. So just today we will be discuss about the simple tricks to write the electronic configuration, and then isotopes, isobars and isotones, and also isoelectronic species. Right. Thank you.